ladies and gentlemen. Welcome to Kino Training Systems. I'm Kino Thomas. Today we are going to do a flight familiarization video on the Cessna 172. And it's pretty neat. Little baby plane parked to a big giant plane. At any rate, this is the Cessna 172, commonly known as a Skyhawk. This is a four-seat aircraft, generally used in aviation. It's actually widely used. This is the first aircraft that I've ever flown in, and it's pretty cool because in simulation I can do a lot of things, and it's cheap because all you have to do is sit down and watch a video instead of actually going to pay a flight instructor or paying for ground school to cover some of the necessary, the necessary things that we need to know if we're going to go and train. So just step right in this video. We're going to talk a little bit about operating limitations, instrument markings, and just some of the limitations that are associated with the Cessna 172. We call it a Skyhawk. Sometimes that is the nickname of this aircraft. So let's just jump right in. I'm just pulling up my talking points really quick. We'll go into the aircraft. We'll go into the inside of the aircraft. This is basically what it looks like on the inside. And this is a very, very good representation of what you would see as you sat inside of the aircraft. Let's see here. We're going to talk about airspeed limitations first. Okay, so the airspeed limitations. Let's just see if we can zoom in. You know what? No, I got a better view. Okay, there we go. Let's talk about airspeed limitations. All right, so we have what we call V speeds. V meaning velocity, and speeds are the limitations that we have to be aware of. Anytime you fly an airplane, you have to make sure that the pilot operating handbook that is associated with that aircraft, with the weight and balance data, you have to make sure that is inside the aircraft, or it is not legal to fly. Let's jump into limitations first. Never exceed speed. It's 160 knots. This is the airspeed indicator. It is not like your speedometer in a car, because your car measures speed in miles per hour, which are considered statute miles. In airplanes, we measure in knots. So these are nautical miles, commonly associated with boats. The difference between a statute mile and a nautical mile is about, the nautical mile is 15% bigger. So 1 nautical mile an hour would be 1.15, or just to simplify, if I was moving at 100 knots, I would be moving at 115 miles an hour. Okay, so here we have our airspeed indicator. We have a red radial line here. This is marked at 160. It's calibrated at 160 knots. That is VNE, which is the never exceed speed. Maximum structural cruising speed is the top of the green arc, and this is 128. We have speeds that are not one speed or V speed that is not labeled is VA, which is called the maneuvering speed, and it varies with different weights. At 2,300 pounds, the maneuvering speed is 97 knots. At 1,950 pounds, it's 89, and at 1,600 pounds, it's 80. And at maneuvering speed, we can put in full control inputs. And let me just So we could put in full control inputs on the control yoke at the speeds. If we are at a higher speed than that, then we could possibly cause structural damage to the aircraft, and that is a no-no in the air. We do not want to be causing structural damage because we want the wings to stay on and we want the aircraft to stay solid. The next is the flaps extended speed, or maximum VFE, which is the maximum flaps extended speed, and it is marked here at 85 knots. The white arc tells us this is the flap operating range. The green is the normal operating range, and at the top is maximum structural cruising speed. This is the speed. We don't want to go any faster than this. We don't accept this. We don't exceed the speed unless we're in smooth air, no turbulence. This yellow arc is the caution speed range. All right, so we want to make sure that we're not in this speed regime in turbulence, because then we could possibly cause structural damage to the aircraft. So, talked about the white arc. The white arc runs from 41 knots to roughly 85. That's the white arc. Then we have the green arc that goes from about 47 knots, slightly below 50, because we got 40, 45, 50, 55, 60, 65, 70, and so on. That's how it's calibrated. The yellow arc goes from 1 to 8 knots to 160, and the red radial line that we'll talk about all my private pilot people that are going to be taking the written exam or the computer test examination for the Federal Aviation Administration test. You need to be familiar with these speeds. So white arc covers the flaps, green arc is the normal operating range, yellow arc is the caution speed range, and VNE, which is the never exceed speed. We never ever want to be above 160 in this aircraft. And these markings would vary for different types of aircraft. This airspeed indicator is built and calibrated for this particular aircraft, so we need to be mindful of that. I am going to do a video on the engine, but if we go outside, we can't really see the engine. The engine is inside here, and it's housed in what we call a cowling. But basically, the engine manufacturer is Avco Lycoming. The engine model number is the O320-320 H2AD. That is the model number. Our operating limits for takeoff and continuous operations is one has 160 brake horsepower and a maximum engine speed of 2,700 RPMs. Let's go back into our aircraft and let's look at the panel. So this is our tachometer. This measures how fast that the engine or propeller is rotating. All right. You see RPM times 100. So this is 500 RPMs, 1,000 RPMs. We're just basically adding 2 zeros to the single or double-digit numbers. So as the aircraft is rolling, we typically idle at 1,000 RPMs. And then again, green, the normal operating range. 2,700 is right there. All right, so you're going to have to become familiar a little bit with these aircraft or engine instrument markings, because green is always good, red is always bad. You know, it's like green, go, red light, stop. All right, so there's some consideration that is taken into marking these engine instruments to let the pilot know, hey, the airplane is telling you that it's in a bad position whenever we're in the red range. Here we can see that the fuel needles are down. That's because the engine is off and the electricity is off. And so we have the fuel sensors are not giving us or displaying the right fuel quantities. Fuel flow. Let's see here. All right. EGT, exhaust exhaust gas temperature, fuel flow. Whenever we're operating this aircraft, and definitely when we're in flight, we want to be in the green arc. Here, oil temperature. This is the oil temperature gauge. The green range is the temperatures that you want to be in. As far as temperature, on this side, you don't want to exceed 245 degrees, and then we have pressures. This is in PSI. Let's see here. We have a turn coordinator. We'll talk about that later. The attitude indicator is not running. It's not operating. Again, the aircraft is off. So right now, what I want you to just basically worry about are these basic 6 flight instruments: the airspeed indicator, the attitude indicator, the altimeter. This tells us how high we are above sea level, and this needs to be adjusted to right about there. Trenton Mercer Airport is 213 feet above sea level. Alright, so we want this needle to be slightly above the 2. It's saying 205 now. I'll bump it up. No, it's saying 214, so okay, that's a more reliable, better indication. Continuing, this is the turn coordinator. This tells us, this is an indicator to the pilot when they're turning. It gives you the quality of the turn. Whenever you make turns, this ball should be centered. If it goes into the outside, then it's uncoordinated flight, and we call that a slipping. If it's on the inside, it's skidding. So basically, if the ball goes to the outside, we want to step on the right rudder pedal, and I'll cover that in a minute. And if the ball slid to the into this way, let's say, and I need to back up a little bit because it depends if you're making a right or left turn. If this aircraft was making a right turn, this wing will be slightly downward. This is a miniature representation of the airplane. This wing will be upward. And a slip would be indicated when the ball is in the right side of this ball. This is called an inclinometer. Alright. And when it's in the center, that means you are in coordinated flight. Here we have a DG, Directional Gyro, or heading indicator. Currently, it's looking at 73 degrees. I like my little helper there. Marker 73 degrees. So north will be considered 0 or 360. So there are 360 degrees in a circle. So in a circle, we could be turning. We could be going north, east 090 degrees, south 180 degrees, west 270 degrees. And then we have some markings here to kind of help you. If I was on this heading, it would let me know about 120 would be the heading I would need to make if I was going to go turn to a heading of, it would be 45 degrees. So there's a 45 degree marker, a 90 degree marker. And we'll go in depth with this. The sixth one that I want you to be familiar with is the vertical speed indicator. Vertical speed indicator tells the pilot how fast the pilot is climbing, if it's up or descending, and we have our up marker and down marker in feet per minute. Again, we have 100 feet per minute, so we add 20. So if the needle was up here, we would be climbing at 500 feet per minute. So 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000 feet per minute. We could be climbing or descending at 1,500 feet per minute. So this needle kind of floats up and it goes down. I have a video on how these instruments work. It's very important that you note that. I have them in the instrument pilot ground school and the private pilot ground school. Because as pilots, we need to understand the operating limitations and errors that could be associated with these flight instruments. The PETO, if you covered the ground school, and that's why I highly encourage you to look at the private pilot series. The PETO tube feeds this instrument. All right. And as well, the static port feeds it as well. So PETO tube takes in ram air pressure, and balances it with static air pressure. This is operated by a gyroscope. So is this one. So these are gyroscopic instruments, the attitude indicator and the heading indicator. This is an electrically operated gyro system. These are vacuum powered. You could see vacuum there and the word vacuum there. So it's telling you, hey, the vacuum system is powering me. This one says DC, which means direct current electricity. So this is an electrically operated gyro. And this is a form of redundancy. When I say redundancy, that's a big word. It just means I'm backing up. I'm using something else. And a different system. In case the gyroscopic instruments fail, this can give me a little bit of, if this is in this position, then this indicates that I'm not turning, I'm flying in straight level flight. Static instruments, attitude indicator, vertical speed indicator. So we have our fuel tanks. We have a left fuel tank, right fuel tank. EGT fuel flow, we'll cover that later, but oil and temperature pressure need to be in the green. The vacuum system as the suction gauge, this is called a suction gauge. We have a vacuum system that applies a vacuum for these gyroscopic instruments. And it needs to be in the green arc, and then our amperage is, we have an ammeter here that gives us our electrical information and let us know what's going on with the system electrically to make sure that all the electrical components are going to be okay. Now, here we have circuit breakers. How we test them is we just run our fingers across them, just apply pressure, push them in a little bit. And if they don't pop out, they're fine. If they do pop out, then that is bad. We have a master switch that powers up our electrical system. As I turned it on, the clock came on, the fuel gauges are saying, hey, we're full. There's no fuel flow going on. There's nothing going on with the temperature and the oil pressure, but the electrical system says, hey, I'm up and running. I turn it off, and everything goes off. So this powers the electrical system. This is a split switch. We have an alternator, and we have a battery system, and if the alternator's on, okay, trying to, so there we go. I wanted just the alternator on, but it just clicks on the battery, and we'll touch that out. Let's see, these are navigation instruments. We will not cover that now. We'll do a video later on navigation, but this is the Omni Bearing Selector, OBS, Omni Bearing Selector. This is OBS1, OBS2, and this is a ADF, or Automatic Direction Finder. We have fuel pump, beacon, rotating beacon, landing light, taxi light, navigation light, strobe lights, and we have pitot heat. In cold temperatures, the pitot heat needs to be warmed so it doesn't get iced over, or we don't want any precipitation like snow or freezing rain buildup. Let's see, this is a panel light. This is a rheostat, and I could rotate this to turn the panel lights up a little bit higher or low. That's what a rheostat does. And this is alternate static air. We can turn that on or off. This is redundancy or a backup for the static port. Outside the aircraft, we have throttle. This is your gas pedal, and we have mixture. As we increase altitude, if you've looked at any of my other videos, atmospheric pressure decreases. So we don't need the same amount of fuel flow to diminish atmospheric pressure. And then we have a flap switch. The flaps, again, from my private pilot videos, you know what flaps are. But we can set the wing flaps for 10, 20, and 30 degrees. And then we have a pitch indicator, and I'm just pressing that, and I'm rotating this down to the takeoff position. You see TO, that is the takeoff position, not Terrell Owens. And then we have a fuel shutoff system here. Here we have a fuel selector switch. We can draw fuel from both, and we can take fuel from both tanks. We can rotate this to the right. And it should be rotatable. apparently it is not in the simulation. We can rotate this in real life to the right tank if we just want to draw fuel from the right tank, and we can rotate it to the left and just draw fuel from the left tank, or we can just leave it in the both position to draw from both fuel tanks evenly. Now normally, this is the normal flight situation. If there was some reason, some type of engine problem or something like that, or maybe something was messed up in the right fuel tank, then we could just rotate this to the left and just draw from the left tank if we were just going somewhere to have it looked at by a mechanic. Let's see what we have here. We have our communication, nav radios 1, communication 2, nav radios 2, the ADF, DME, distance measuring, the transponder. This gives the radar facilities, this lets us know, hey, this is our airplane. And then we have an autopilot here. Placarding. Alright, now, just to talk a little bit about placarding. Now, in the POH, in most Cessna POHs, it will give you maneuvering speeds. When an aircraft panel is placarded, meaning there's a notice, that's what a placard is. It's a card of notice. This is for this airplane, the maneuvering speed is 105 knots. This would probably be at the highest weight, and you would consult the pilot operating handbook to give you an idea of, if we are at lighter weights, what the new maneuvering speed would be. One thing I did not cover, up here we have a vacuum system. Annunciator panel. The annunciator panel is lit. It lights up when it's telling the pilot, hey dummy, our left and right vacuum system is out. There's no oil pressure. We're having a problem with voltage, meaning that electricity is being drawn, but it's not the electrical system's out of whack. Now, just like your car, you have a battery and you have an alternator. Okay. In your car, you have a battery and you have an alternator. What the battery does, it just starts your car. All right, just starts your car. So after it runs and you're driving, then the alternator puts the electrical energy back into the battery for future start. If the alternator is working properly. If it's not working properly, like some of you have had problems with your cars where you drive to work and you come back outside to go home or go to lunch and the battery's completely dead. That is an indication that possibly that your alternator was not feeding the electrical energy back to the battery. So, just like airplanes in your car, the battery holds electrical energy. When we fire the plane up or you turn your car on, then the alternator starts running and it slowly recharges your battery back up to full so that you can restart. Now I heard that noise, and it's probably aircraft probably near us that's either taxiing by or firing up. Okay, that's this guy, and I just want to know what the heck that noise was. So we found out what it was. It was the big bird that was with us in the beginning of the video, and they're going somewhere. Okay, I'm sorry, just being nosy, went to see what that noise was. Okay, again, power plant limitations. We told you what type of engine, manufacturer, maximum speed, oil pressure, and all that. We're not going to go into that in this video. Maximum takeoff weight in this aircraft is 2,300 pounds. Maximum landing weight is 2,300 pounds. You have a baggage area. The baggage area is right here. I'll zoom in. There's a baggage area, and then there's a cross there. There's a first aid kit back there. You will pull a lever, and this will be open. And you can see the pilot, co-pilot seats up front. And you can see 2 seats in the back. And behind the passenger seats in the rear is the baggage area. Maximum baggage in this compartment. What is the max capacity? I'm just looking at the... so I haven't flown this. 50 pounds. So you can put 50 pounds of baggage in this compartment safely, and it should not affect the weight and balance, but you would do a weight and balance computation just to make sure that the aircraft is loaded properly within limits. Up here, these are the fuel caps. This is where the fuel is put in or pumped into the aircraft. So the fuel tanks are in the wings, and here you can't really see it that clearly, but there are more placards here that says what type of fuel. Typically we use 100 low lead, which is blue fuel. It's blue. It has a bluish tint to it, I should say. I shouldn't call it blue fuel. Just covering my talking points, and that's typically what we're going to cover right now at this stage of the game. For any comments, questions, and concerns, well, I think what we will do, we won't cover pre-flight. I'm actually going to do a pre-flight on a real Cessna 172 and videotape it once I get some cameras that I've ordered. So let's just go through the checklist. Right. Okay, this is the virtual cockpit view. This is a realistic view, and the controls are totally operable in this section. Well, actually, I can. Yeah, I can rotate the fuel selector. All right, but we want it in the both position. All right, I wonder. Okay, if there's an off position. No, there's no off position. All right, so we would make sure that the mixture is rich. This is the mixture. Out would be idle, full cutoff to cut off fuel to the engine. When we push this in, it is rich. So mixture rich. This will be mixture lean. All right. Carburetor heat cold. So is that there? And let's just go to our. All right. Now this particular aircraft does not have. It's a fuel injected system, so we don't need carburetor heat. I have to find a plane makeup with a carburetor heat switch. Okay, let me just cut that radio off. We have certain frequencies here, and this is the active frequency, this is the standby frequency, and this is a swap or a switch to standby. So I can make 128.25 flip to this side, to the standby side. Alright, let's see here. Alright, so the mixture's rich, there's no carb heat. Master switch on, the master switch is on. So the alternator and battery switch is considered the master switch, and it is labeled as such. It's on. We don't need to prime the engine. We push the throttle in about 1/4 of an inch. Full throttle is all the way in and out. So this would be synonymous with pressing your gas pedal down, and this will be taking your foot off the gas. So we just push that in just a little bit. Alright. And what we need to do, commonly what we do, is we turn our rotating beacon on. When we turn our rotating beacon on, what this does is signal to anybody walking around our aircraft, pilots and ground crew, that, hey, my engine is about to start. So that is the purpose of that. When you see the red rotating beacon or the red light flashing, stay away from the engine. In jet engines, since there will probably be two engine nacelles, or power plants, I should say, hanging off the wings, and you would want to stay away from them when you see this red light. Now, that is the visual indication, in case people, because a lot of people have hearing protection on, and they may not hear you when you say clear prop. But typically what happens, you could either open your door, or you could open the window, and you would just lean your head out slightly, and you would say clear prop, P-R-O-P, clear prop. Anybody that can hear you would say, okay, his engine's about to start. Anybody wearing hearing protection can look and say, okay, boom. So when you're walking around the flight line, you want to be, just mindful of that. Sorry. So then after that, let's go back into and let's see, they don't give us the key. Alright, no problems, no worries. Alright, so what we're going to do is we are going to try to zoom in. It's not letting us. Alright, let's see. And I just started working with this cockpit. Now, with this, you can't see it. I'm going to figure out a way to zoom in on this so you can see it. But there's an off, left, right, both position, and start. When we start it, we turn the key to the right, as you would in your car. Actually, if you were looking at your hand when you start your car, you basically grab the key, you turn it to the right. Okay. And now it's the parking brake. Now, clearly, we can hear that the engine is started. We can see that the propeller is rotating. Alright. Let's close the door. Alright. Exit closed. And shift forward. Now, some things we can see now. Before, when the engine is off, the fuel flow was not. It was actually down. Alright. The EGTs come up. The oil temperature is going to start warming up, but it is in the green arc, and the pressure is below. If we just throw our throttle in, just fire it up a little bit, we'll see that the tachometer, or revolutions per minute, of the propeller is increasing, and the pressure also built up. Okay, so we can see that. We typically idle at 1,000 RPM, so we'll gently push the throttle a little bit, so it idles at 1,000. That's where we want to be at. So after starting the engine, the first thing we want to look at is our oil pressure. Alright, so our pressure is not up. Just turn that fuel pump on. Alright, so that's basically the starting engine and initial familiarization. We're going to do another video, but we'll cut this one right here. And I'd like to thank you guys for watching. I hope you guys like this video. This is Keno Thomas with Keno Training Systems, and this is our initial Cessna 172 SP familiarization. Thanks for watching.